Well, hello everybody. Let me show you what I got going on with you today. As I jump around a little bit here. Hey, what I need to do with you, you FST students, is I need to cover day 3 with you in our chapter 8. The items that you will need today to have on hand, you need that note card that we have those formulas on that we've been using for arithmetic and geometric sequences. Today what I do is I take you from sequences into series. The only difference between a sequence and a series, though, guys, is one deals with addition, that's the series. The other deals with terms, so commas. The arithmetic part still means you're adding from term to term. The geometric part still means that we're multiplying or dividing from term to term. You will also need your day 3 class examples in front of you. So, also, if you're gone, we did have a grade raising opportunity, so make sure you get in and get that caught up, aka homework quiz. So, if you would, let's get straight into kind of where we're going today. Here's where I need to go with you first. A little short story about where one of the formulas comes from. So, I need to tell you a little story about Carl Gauss. Carl Gauss had this assignment. When he was 8 to 10 years old, the story varies just a little bit there, but when he was 8 to 10 years old, the teacher gave this assignment to the class. They said, hey class, what I'd like for you to do is add up the first 10 numbers. So if you would, add up 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there's the assignment part of it right there. And then the teacher said this, as soon as you're done, add up the numbers 1 through 100. Add up the numbers 1 through 100. Now, here's where the story diverges just a little bit. One story says that Carl did this. While the teacher was on the way to her desk, Carl said, well, this answer is 55, and this answer is 5,050. One version of the story says that the teacher says, Carl, that is awesome. Nice job. Tell the class how you did that in your head. The other story goes like this. The teacher says, Carl, please get busy. And Carl once again says, well, I'm sure the answer is 55, and I'm sure the other answer is 5,050. The teacher, having no clue, said, Carl, now you're being a smart aleck. Please get busy on today's assignment. Carl said, once again, it's 55 and 5,050. Well, the teacher kicked him out of school, sent him home. Well, later on that evening, she sat down and totaled him up to see if he was right, and of course, lo and behold, Carl was. But here's what Carl did. He says, the teacher would like for me to add up all the numbers 1 through 10. He reversed those numbers, so he's using them twice. The reason he did that, look what he wound up with over and over and over. He had 11 added together a number of times. So Carl said to himself, well, I'm adding up 10 numbers whose total comes to 11, but I'm going to divide it by 2 because I listed the numbers twice. And then in his head, 2 went into 10, 5 times 11. Lo and behold, that answer was 55. I'm going to put this in a formula here for you on your note card. That's why I'm telling you this quick little story. And then he went down to the 1 through 100. Did the same thing. Here's the part that the teacher wanted. In his head, he reversed them. And the reason he did that, he said, well, I'm going to get 101 if I add vertically a number of times. And to be truthful, if you really think about it, he got 101 100 times. 100 times he got 101. But he knew he listed the numbers twice, so he divided them by 2. Still in his head, this is what's impressive. 2 went into 100 50 times, so he took 5 times 101 and got 505 and added a 0. The reason I tell you this little story, we're going to take this little 8 to 10-year-old's thinking and we're going to come up with a formula for it that works for any arithmetic sequence that becomes a series. Let's look at where Carl got this 11 and 101. He got that 11 and 101 by taking the first term and adding it to the last term. 1 plus 10 or 1 plus 100. He then multiplied it by the number of numbers that he needed. And he then multiplied it by the number of numbers he needed and then divided it by 2. So guys, if you look on your note card, you should have a formula that looks like this. Here's what this formula says. As long as it's arithmetic, to sum up your numbers, the number of numbers that we're multiplying or adding together, divided by 2, times the first term and the nth term. I'll lead you through starting on your notes right now. So if you would, come over to your number 1. What it says is I need to add up the first 6 terms generated by the sequence that goes 3n minus 5. Just so you can see what we're doing, and since there's only 6 terms, I don't mind listing this out. I'm going to plug in a 1 to find the first term. 3 times 1 is 3, minus 5 is negative 2. The Greek letter sigma means I'm adding them up. Now I'm going to plug in a 2 to get the second term. 3 times 2 is 6, 6 minus 5 is 1. I'm going to plug in a 3 to get the next term, a 4 to get the next term, a 5 to get the next term, and a 6 to get the next term. Well, let's look at this total real fast. 13 and 10 is 23, plus 7 is 30, 34, 35. This total should be 33. Well, that one's not bad to do by hand because there's only 6 terms. Later on, this will become a 60 or a 600. So let's look at the key things for Carl's formula here. A sub 1 is negative 2. A sub 6, my last term, is 13. N, the number of numbers we're trying to add up, is 6. Well, check this out. Here goes my formula. I'm going to say that the sum of these 6 numbers is 6 divided by 2, there's your n over 2, times negative 2 plus 13. At this moment, guys, you could grab your calculator and run that straight through. Since these are little numbers, this really becomes 3 times 11, so there's my answer of 33. Okay? Rest of them, I'm going to show you Carl's formula. So that way it'll become a little quicker for us. Now I'm going to click right through it a little bit. Now, here goes my number 2. Guys, the things that I need the value of the first term. In this case, I need the value of the 5th term, and I need the number of numbers that we're working with. I'm going to plug in 1 to get the value of the first term. 2 times 1 is 2, plus 3 is 5. 2 times 5 is 10, plus 3 is 13. And I'm adding up 5 numbers. Here goes the formula. The sum of these first 5 terms can be found by 5 divided by 2 times 5 plus 13. Either grab your calculator or grab your brain. This becomes 5 halves times 18. 2 goes into 18. 9 times 5, my answer, 45. That's all there is to that formula. I'm going to click through the next ones, and I'm going to switch gears and show you how we do geometric series. So here goes my number 3. It says sum up the first 7 terms. Well, once again, guys, I need k sub 1 or a sub 1. That part doesn't matter. I need k sub 7 and my n value. So to get k sub 1, plug in 1 into this formula. Negative 5 minus 1/4 times 1 is negative 5 1/4. Plug in 7. Negative 5 minus 1/4 times 7, you're going to get negative 6.75. And n happens to be the 7 numbers that we're working with. Here goes. The sum of these 7 numbers can be found by 7 divided by 2 times negative 5.25 plus negative 6.75. Grab your calculator, grab your brain. This becomes 7 halves times negative 12 12, 2 goes into 12, negative 6 times 7, so I know this answer is negative 42. Okay? There's what we are so far. Let me get just a little bit more room here. On my example number 4, says, find the sum of the first 50 positive numbers. This one's got a little twist to it. Well, my first term would be 1, of course. My second term would be 2, 3, 4, 5, dot, 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 up to the 50th term, which happens to be 50. So, guys, my ace of 1 is 1. My ace of 50 is 50. Now be careful here. The number of terms that I have is 50. Two ways to get that. We got 50 numbers, but 50 minus 1 tells me there's 49 numbers, but you always add 1 back. So here goes. The sum of these 50 numbers can be found by 50 divided by 2 times 1 plus 50. Okay? If you run that through your calculator, guys, you're going to get 1,275. So arithmetic's not bad at all. Number 5 is a big one. Hopefully I'm not going too fast here on the video. I don't want my video to be too long. We're summing up the first 500 terms that goes by 23n. So I'm going to go 23, 46. So looks like these are going to be pretty huge. So on my number 5, my ace of 1 is going to be 23. My ace of 500 is going to be 23 times 500 is going to be 11,500. And my n value is 500 numbers. Well, here goes to get these 500 numbers, the sum of. I'm going to go n over 2, so I'm going to go 500 over 2 times 23 plus 11,500. Okay? And guys, just simply run that through your calculator. And what you'll do is you'll see a number that resembles my monthly teaching salary of $2,880,750. Okay? I'm going to skip number 6 because it's just like 1, 2, 3, and 4 that we've done so far. Okay? Now number 7's got a little twist to it. Number 7's got a little twist to it. It says the sum of the smallest k positive numbers, multiples of 5, is 275. Figure out how many numbers that is. Well, picture what we're doing here. We're taking 5 plus 10 plus 15 plus, I don't know where to stop, but I know when I get done, my total is going to be 275. This one's got a little bit of work to it. I'm going to start off with my formula that we've already worked with. The sum of these numbers is n over 2 times ace of 1 plus ace of n. The bad thing with this problem is we don't know ace of n. That's what we're trying to figure out what term it would be. So when I start working with this so far, I know my ace of 1 is 5. I don't know my last number. And I don't know my n. So here's what it's going to start looking like. I'm going to still use this formula that says S of n equal n over 2. I do know ace of 1 though. That's going to be 5. I'm going to look at my note card. Ace of n doesn't help me right now, but I have a definition of ace of n which says it's ace of 1 plus d n minus 1. So I'm going to continue to build with this. This now becomes n over 2 times 5 plus 5. Ace of 1 is 5. My d value happens to be 5. So if I distribute, I'm going to have 5n minus 5. So here's a semi-formula for me. I got n over 2 times 5n plus 5. I combine that and that and that. And guys, what I'm going to do now is I'm going to set this equal to 275. That's what I want my term to wind up being. Here comes the hard part now. You're probably already thinking, well, wait a minute, that's kind of hard anyway. I'm going to give myself some room to work right back here. What I'm going to do now is I do not like this 2. So what I'm going to do is multiply both sides by 2, and then I'm going to start solving it. So if I multiply through by 2, I'm going to have 5n squared plus 5n equal 550. So guys, what did I do? I multiplied by 2, canceled that out, and distributed. I'm going to write this as 5n squared plus 5n minus 550 equals 0. This takes you now back to your Algebra 2 days. I'm going to divide everything by 5 so that I could factor this thing. So I've got n squared plus n minus 110. And then now we're going to factor. Two numbers that multiply to be 110 that I can make add up to be 1. It's going to be n plus 11 times n minus 10. Solve that. I'm going to get 10 for the number of terms that I need to work with. So my answer is 10. Okay. If you struggle with that one on the assignment a little bit, trust me, we're going to be doing it in class again. So there's the first part of the lesson. Okay, guys, I'm going to switch gears on you now. I need to show you the geometric series. Remember, a sequence is geometric if it's multiplied or divided by the same number. Same thing here. But now, guys, there's 2 formulas on your note card. You could use either of these formulas any time. They both work on any geometric series. For the sake of this video, I'm going to use this one over and over and over. Some little things I want to point out, though, before I do that. G sub 1 represents the first term. Notice that this is r to the n and then minus 1. Notice that it's not r to the n minus 1. Okay? So notice that. And then once you see it, I'll ask you to type it a certain way in your calculator. If I get going too fast, guys, hit pause on the video for a second, run it through your calculator, and make sure that you understand. Okay? So guys, pop over to your number 1. I'll skip the chess example for now. We're going to sum up the first 6 terms that's gone by the series of 1/3 to the n minus 1. Guys, when you have a something in parentheses to the n or the n minus 1, it will always be geometric, and your r value will be whatever's inside your parentheses. Always. But just to kind of show you what we're going to have going. In this case, I need G sub 1. So plug in 1. 1 minus 1 is 0. 1/3 to the 0 is 1. I need my r value. Well, my r value is 1/3. And I need my n value, which is 6. Now, pause the video after we set this up and make sure you can run it through correctly. But here's what it looks like now. I'm saying the sum of these 6 terms can be found by, I need G sub 1, which is 1, times my r value to the nth power. Put your r value in another set of parentheses. Always do that. So your r value in a set of parentheses to the 6th power minus 1 over parenthesis my r value minus 1. Okay, guys, I'll pause just a little bit here. You will run this through your calculator now exactly the way this looks. You'll go 1 parenthesis, another parenthesis for your r value, 1/3 to the 6th minus 1, close that parenthesis out, divided by another parenthesis, 1/3 minus 1. Now guys, we want exact values when possible. After you do this, you're going to get some decimal. You're going to hit Math Enter Enter. And if you ran this through correctly, you should get an answer of 364 over 243. That's the number we want, not that 1.4979 number. Be exact when you can. And with me saying that, the next one we can't be exact on. But that's what we want. So if you need, pause that video. Make sure you ran the calculator part okay. Guys, here goes my number 2. I need out of this, I know it's geometric because I got a parenthesis to a power. I need G sub 1. I need my R value. I need my N value. Well, plug in 1 once again. 1 minus 1 is 0. Negative 3/5 to the 0 is 1. It is not always 1 for the first term. It just happened to be on this. My R value is negative 3/5. My N value is 11. So here's what it looks like. The sum of these 11 geometric terms is going to be found by G sub 1, parenthesis, another parenthesis. If you forget the second parenthesis on this one, you will find the wrong answer. So negative 3/5 to the 11th minus 1, close that parenthesis off, all over parenthesis negative 3/5 minus 1. So G sub 1, R to the N, and then minus 1, parenthesis negative 3/5 minus 1. Guys, this one does not come out to be an exact number. You can't go Math Enter Enter on this one. So you should get about 0.6273. About 0.6273. Once again, you might pause the video for a second, grab your calculator and make sure that you can do that. Here goes my number 3. This one happens to be recursive. Big deal. I know it's geometric because I'm multiplying right there, and there's no addition or subtraction back here. So things that I know, G sub 1 is 70. We're summing up the first 5 terms, so N is 5. My R value is going to be negative 4. The setup, the sum of these 5 terms can be found by 70, parenthesis, your R value, parenthesis, negative 4 to the 5th, minus 1, close your parentheses off, over negative 4 minus 1 in parentheses. If you use your calculator correctly, you should get 14,350. Okay? My number 4, the geometric series that goes 18, 6, 2, ... to 2 over 81. A little twist on this one, but not bad. I need a G sub 1 value, which in this case is 18. I need an R value, which in this case to go from 18 to 6, 6 to 2, looks like my R value is 1/3. I also need an N value. To get in the number of terms you're using, we're going to use your calculator or your brain to figure out how many terms we're doing. And since I don't want to pull my calculator up, I'm going to use my brain. So guys, here's what I've got so far. 18 is the first term, 6 is the second term, 2 is the third term. Let's quickly multiply by 1/3. Don't even touch your calculator. 2 times 1/3 is 2/3. So I'm up to 4 terms. Multiply by 1/3 again. I'm up to 2/9. I'm going to do this until I get to 2 over 81. Well, that didn't take me long. So notice I'm working with 1, 2, 3, 4, 5, 6, 7 terms. Now we're ready. The sum of these 7 terms can be found by 18, parenthesis, 1/3 to the 7th, minus 1, over parenthesis 1/3 minus 1. Okay. This one can come out nice. If you type it in, you should get 2186 over 81. Okay. I'm going to skip number 6 on this one. I will show you number 5 real fast, because this is an expression for the sum. It doesn't come up with the number. Your calculator really doesn't help you any. So on number 5, we're going to sum up the first 10 terms of x to the 5th to the n minus 1. But I'm going to play the same game. G sub 1 is going to be the term I get when I plug in 1. 1 minus 1 is 0. X to the 5th to the 0 is going to be 1. My n is 10. My r value looks weird. It is x to the 5th based on this problem. Well, here goes. The sum of these 10 terms can be found by g sub 1, 1, r x to the 5th to the 10th minus 1 all over x to the 5th minus 1. Your calculator doesn't help you any. All I can do to clean this up now, leave that 1 alone. X to the 5th to the 10th is x to the 50th. You multiply your exponents. Minus 1 over x to the 5th minus 1. There's the answer in this case. I'm going to skip number 6 because it's just like number 4. So we'll skip that one. Pop over to number 7 and number 8. I'll show you that setup, and then we'll go. On her birthday every year, starting at the age of 22, until retirement of the age of 67, Beth plans to deposit $1,800 into an IRA account. Suppose an IRA account will earn 3.8% interest every year. Part A says, using sigma notation, write the series representing the amount that Beth will have in the account when she retires. Well, here's what it's going to look like. Some things that I have. G sub 1 is going to be $1,800. That's what she's putting in the first year, and then every additional year. My R value is going to be the 3.8% interest, but inside my parentheses I'm going to need 1.038. That way it shows that it's a growth model. The number of years is going to be 67 minus 22 plus 1. 67 minus 22 plus 1, so n's going to be 46. So here's the answer to part A. Using sigma notation, that means there's going to be a Greek letter sigma in there. We're going to go from the first year she invests money to the 46th year. My G sub 1 is 1,800. My R value is 1.038 to the n minus 1. Guys, I want you to notice something here. Notice that this is our geometric sequence formula. I turned it into a series by adding that up. So there's that part. Now, if you run this through your calculator, it's going to look like this. G sub 1 is still your 1,800. Your R value is your 1.038. So we're going to look like this. The sum of these 46 years will be 1,800. Another parenthesis, 1.038 to the 46th minus 1 all over 1.038 minus 1. Okay. And guys, if you run that through your calculator correctly, you should get $216,002.10. To do part C, where it says how much of that amount is interest, think about this. She's investing $1,800 every year, and she's going to do that for 46 years. That's how much money she put in. I'm going to take this amount and subtract it from $216,000, and you'll find that interest-wise, she did pretty dang good. $133,202 and a dime. Okay, and then I got one more. I missed my goal of the video. My goal of the video was to be 30 minutes or less. I'm going to be 32-ish. So here's number 8. It says a ball bounces 2/3 of the height from which it falls. What's the total distance traversed by the ball dropped from 15 feet after it's hit for the 9th time? Okay. Well, guys, some things that I know so far. My G sub 1 is 15. That's where I'm starting. My R value is 2/3. And N is 9. But guys, here's what this is going to give us. It's going to give us the 15 feet for this first time. Then it's going to assume the ball starts again up here, and then starts again down there. Think about what really happens. I'm coming up here at 15 feet and dropping a ball. It's hitting the ground, coming back up and going again. 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 So hang with me on this. The sum of these 9 bounces is going to be 15 times an extra parenthesis, 2/3 to the 9th minus 1 all over parenthesis 2/3 minus 1. Now, we're not done with this one. Think about this. Every time I dropped the ball, it hit the ground and came back up. And then it went down again. And then went back up and down. So I need to double this number. I need to double that number. But there's one height that does not get duplicated. Notice that when I dropped it from 15 feet, it hit, then it came back up 2/3 of that. So it came back up to 10. So I'm going to subtract away 15. There's what we need to run through our calculator to get about 72.66 total feet that the ball moved. So guys, that is section 8-5A. Your assignment is on OneNote unless you needed a paper copy, and you should also have that in your hand. If you have any problems, get in and see myself or Miss Dinahan. Good luck to you.